Hello everyone, myself Sai Prasad, Alex in Ahmedabad High School and the Junior College. Welcome to a series of the lectures of Intermediate Second Year Maths A. We started a discussion with the chapter Quadratic Expression. What did we learn? We learned with the basics of how do we solve quadratic equation, then finding the nature of roots. Okay. Today we are going to learn few relations of that quadratic equation. Okay. See here, let us discuss a theorem. Let alpha beta be real roots of a equation and condition is alpha is less than beta. Okay. Then they are asking us to prove these two things, that if x lies between alpha and beta, then this equation and its coefficient a always have opposite sign. Okay. Next, if x does not lie between alpha and beta, then condition is both ax square plus bx plus c and a will have same sign itself. Okay. There is actually a formula kind of thing, but we will prove it. Okay. See here, first let us assume given alpha beta are roots of ax square plus bx plus c equal to 0. So, can I write it as ax square plus bx plus c is equal to x minus alpha into x minus beta? Can I write this? It is okay, right? So, let us put it like that and let us take the first condition, given alpha is less than x less than beta, that is x lies between alpha and beta. What do this mean? Alpha is less than x, so I can write it as x is greater than alpha and x is less than beta, isn't it? So, from this can I write it as x minus alpha is greater than 0 and x minus beta is less than 0. Can I write this condition? So, just observe, one term is positive, one term is negative. What about the product? That is multiplication of a positive term with a negative term is always a negative term, that is x minus alpha into x minus beta is always less than 0. Is it right? Yes or no? So, let us divide ax square plus bx plus c and a. Okay. What is this numerator? Can I write it as x minus alpha into x minus beta? Let us put a as it is. Okay. Now, if you observe here, this term is this, and we know that this x minus alpha x minus beta is less than 0. Yes or no? If this term is less than 0, obviously both the numerator and the denominator will have different signs. How? If both have same signs, for example, let us say plus and plus, it is okay, it is fine. If both the numerator and denominator are negative, we can cancel and make it as positive. So, it clearly tells that here numerator and denominator are less than 0. So, both are having opposite signs. Therefore, ax square plus bx plus c and a have opposite sign when, what is the condition? Alpha less than x less than beta. Clear? Next, let us prove for the next condition. What is second case? X is less than alpha and x is greater than beta. Let us take case 1. Okay. And remember, x is less than alpha and alpha is less than beta. So, can I write it as x is less than alpha less than beta? Yes. So, I can split and write it as x is less than alpha and x is less than beta. So, x minus alpha is less than 0 and x minus beta is also less than 0. Both have same sign, that is both are negative. So, from this can I write x minus alpha into x minus beta? Negative into negative, it will be positive. Is it right? So, can I do this kind of thing? Ax square plus bx plus c by a is equal to x minus alpha into x minus beta by a. Since this term is greater than 0, obviously the whole term is greater than 0. Therefore, both have ax square plus bx plus c and a have same sign, isn't it? Now, in the same case, let us find for second case. Okay. First was x less than alpha. What was second? X is greater than beta. X is greater than beta. X is greater than beta, and I know that alpha is less than beta. Okay. So, can I write beta greater than alpha? Yes, right. From this I can write x greater than beta and greater than alpha. Yes, so if I separate it, I will get as x greater than beta and x greater than alpha. So, x minus beta is greater than 0 and x minus alpha is greater than 0. Just combine those both, x minus beta into x minus alpha is greater than 0. Why? Because both are positive, obviously the product is also positive. Is it right? So, let us substitute in this formula. What do I get? Ax square plus bx plus c by a is equal to x minus alpha into x minus beta by a, that is nothing but, since it is greater than 0, obviously this is greater than 0. Therefore, ax square plus bx plus c and a have same sign. Clear? As it is, only you have to have that knowledge that the product of two numbers is positive only when both the signs are same. If both the terms signs are different, then the product will be negative. Is it right? Did you understand? So, we have to remember one thing here is, if x lies between alpha and beta, okay, then both will have opposite signs. Second condition, if x does not lie in between alpha and beta, then both will have same sign. Okay, lie within opposite sign, does not lie same sign. Clear? Fine. Shall we move on to the next problem? Let's do. So, the conclusion is, if x lies between alpha and beta, then a and ax square plus bx plus c will have opposite sign. And the second thing, if x does not lie between alpha and beta, that is, it should be either x is less than alpha and x should be greater than beta. If that is the case, then ax square plus bx plus c and a will have same sign. So, one more thing is, what if f of x is ax square plus bx plus c and the condition if a is greater than 0, then f will have a minimum value at x is equal to minus b by 2a, and what is the minimum value is 4ac minus b square by 4a, right. If you remember, you should know this, how we used to do in our applications of derivative, if you remember, maximum and minimum, right. Similarly, if a is less than 0, okay, the coefficient of x square is less than 0, then f will have a maximum value at x equal to minus b by 2 and max value at, maximum value is this. Clear? Fine. With all these basic things, let us start doing the problems. The first question is, discuss the sign of the following when x is real. Okay, this particular thing. Whatever you do, first we have to factorize it. So, this will be 4 table minus 4x minus x plus 4, that is x common, if I take x as common, this will be x minus 4, if I take minus 1, this will be x minus 4, x minus 4 is common, I will get it as x minus 1. Okay. What are the values now? 4 and 1. Okay. Next, here the x square coefficient is positive, yes or no? Then what are the ranges? Here a is equal to 1, which is greater than 0. Okay. Now, we will have two cases, that is for x belongs to 1 to 4 and for x belongs to minus infinity to 1 and 4 to infinity. For the both the cases, we will have two conditions. How? Tell me. For this case, we will have opposite sign. So, ax square plus bx plus c is, since it is greater than 0, which is positive, we have to write it as negative, and here it is same sign, so it will be positive. So, did you understand? Is it clear? Once again, first factorize it, you will get two factors 1 and 4. Okay? Then we always compare it with a. So, we will take two cases, that is x lies between 1 and 4 and x does not lie between 1 and 4. For these two cases, if you remember, for this case a and this equation will have opposite sign. So, it is greater than 0, this will be negative. Fine. Similarly, for this case it should be positive. Did you understand? Fine. Next, see here, for what value of x following are negative for this equation? Okay, let me write it in the form. How? Minus 3x square plus 4x plus 15. For what values of x? Check whether you can solve it. 15 3s are 45, 9 5s are right. So, let us factorize it. Minus 3x square plus 9x minus 5x plus 15. Let me take 3x common, or else minus 3x let us take it as common, it will be x minus 3, right. Here if I take minus 5 as common, I will get it as x minus 3. So, x minus 3 into minus 3x minus 5. So, I will get the values as 3 and 5 by 3. Is it right? This is minus 5 by 3. Clear? So, how do we check that x is negative? First thing is, here a is minus 3 which is less than 0. Okay. Then he is telling that this equation is negative at sums. When do we get negative? That is, it should have same sign. This and this equation are same at sums. In which condition? First or second case? Second case, that is x does not lie between alpha and beta. So, x is less than minus 5 by 3 and x is greater than 3. This is the solution set, or else for these values this equation is negative. Is it clear? Shall we move on to the next problem? Let's do. Look at the next question here. He is telling that for what values of x this equation is positive. So, the same thing, first we have to factorize it, then we will think of the relation. So, the equation is minus 5x square plus 4x plus 2. 5 2s are 10. What are the factors of those two now? 5 2s are 10. Can we solve in order to get 4? Just tell me. No, right? So, we will substitute in the formula. So, this is x is equal to minus b plus or minus under root of b square minus 4ac, 4 5s are 20, 22s are 40 by 2a. Is it right? Minus 4 plus or minus 56 by minus 10. Is it? Minus 4 plus or minus 56 can be written as 4 into 14, right. So, that can be 2 root 14. Is it fine? So, this is minus 2 plus or minus root 14 by minus 5. Yes, so let us separate it. X is minus 2 minus root 14 by minus 5 and minus 2 plus root 14 by minus 5. If we take minus common, we will get it as 2 plus root 14 by 5 and here 2 minus root 14 by 5. So, these are the values of x. Clear? Now, for what values of x this is positive at sums? Just tell me. Here a is negative. Fine. Now, we will have two conditions. Obviously, x belonging to 2 plus root 14 by 5 comma 2 minus root 14 by 5, right. And one more is x does not belongs to 2 plus root 14 by 5 comma 2 minus root 14 by 5. For these both cases, this is positive at sums. For which case? That is, since a is less than 0, we should get a opposite sign. For which condition? For this condition is the answer. Is that right? This doesn't value. You understood, right? Fine. Next question. Find the maximum and minimum values of this following equations. What is the formula for maximum? That is 4ac minus b square by 4a. When do we tell it is maximum or minimum? That is a is less than 0 or greater than 0. Then only we will tell whether it has a maximum or minimum value. Clear? So, write this in the standard form, x square plus 12x minus 32. What is coefficient of x square? Minus 1, which is less than 0. Then it has maximum value. What is the maximum value now? Max value is 4ac minus b square by 4a. Yes. So, what is b here? B is 12, c is minus 32. Let us substitute it, 4ac minus b square divided by 4a. Okay, 4a is minus 1 here, 4ac minus b square by 4a. Done. See here, plus 4 2 is 8, 3 4 is 12, 128 minus 144 by minus 4. 128 minus 144 is 16. Yes, minus 16 by minus 4, that is 4. The maximum value is this. Done. Okay. Next, ax square plus bx plus a. What is the maximum value for it? Let us substitute it. Let us take a is equal to small a, b is equal to small b, c is equal to small a again. Right. So, we can have two conditions. We do not know whether the a is greater than 0 or less than 0. It itself is a constant. So, let us find the value first. Max or min value is equal to 4ac minus b square by 4a. Okay. That is, let us put everything in capital or else, 4ac minus b square by 4a. Done? Fine. 4a minus b square by 4a. This is 4a square minus b square by 4a. Clear? That is a value whether it is minimum or maximum. Then when can you say it as minimum? If a is greater than 0, min value is 4a square minus b square by 4a. If a is less than 0, max value is 4a square minus b square by 4a. Clear? Is it okay till now? Shall we move to the next problem? Let's do. Look at the next question here. Here ax square plus 2bx plus c equal to 0 and ax square plus 2cx plus b equal to 0 have common roots. Then show that a plus 4b plus 4c is equal to 0. So, how did we do in our previous things? Just we will assume that common root which is it. So, let alpha be common root. So, we will get the root as a alpha square plus 2b alpha plus c is equal to 0 and a alpha square plus 2c alpha plus b equal to 0, right. Thus, we have to substitute alpha in the place of x. Next, we will just subtract it. So, subtract, these both will get cancelled. Here, if I take 2 as common, I will get b minus c into alpha plus c minus b equal to 0. Yes. So, 2 into b minus c into alpha equal to b minus c. B minus c will get cancelled, I will get the alpha value as 1 by 2. Just substitute the value of alpha in one of the equations. What do we get? A alpha square plus 2b alpha plus c is equal to 0. Just a into 1 by 4 plus this both will get cancelled, 2b plus c equal to 0, sorry, b plus c equal to 0. Let us take LCM. I will get it as a plus 4b plus 4c whole divided by 4 equal to 0. Therefore, a plus 4b plus 4c is equal to 0. Yes. So, that is what he asked us to prove. Clear? Next, If this equation and this equation has a common root, how do we find? We can't even assume there. First we have to find the roots of this. It is easy to do. Yes? Okay. So, let us find roots of this x square minus 6x plus 5 equal to 0. That is 5 ones are 5, minus 5x minus x plus 5 equal to 0. I can take x common, x minus 5, minus 1 common, x minus 5 equal to 0. After taking x minus 5, I will get x minus 1 equal to 0. Therefore, the values of x are 5 and 1. So, we will substitute both 5 and 1 here. Case 1 for x is equal to 5. 5 square minus 12 into 5 plus p is equal to 0, that is 25 minus 60 plus p equal to 0. What is 25 minus 60? 35. Minus 35 plus p equal to 0, p equal to 35. Similarly, for case 2, for x is equal to 1, let us substitute there. 1 minus 12 into 1 plus p equal to 0, that is 1 minus 12 plus p equal to 0 minus 11 plus p equal to 0. Therefore, p is 11. Okay. We do not know which is the common root among these two. So, I can directly write, therefore, p can be 11 or 35. Clear? Did you understand? So, these are the basic questions of quadratic equation for today. Clear? Fine. This is for today. Let us wait in the next session with the more problems of quadratic equation. Thank you.